Milliseconds after the thermal flash, the incident shock wave reaches the ground and expands, trailed outward by the usual reflected wave. Then a new wave, the precursor, begins to build out from the base of the incident wave, racing ahead through the heated air layer. An intense dust cloud follows closely, rising initially to about 50 feet and later to several hundred feet. One important effect of the precursor is to lower peak static pressures without a corresponding reduction of dynamic or wind pressures. The precursor builds steadily in height, but does not seem to inhibit formation of a Mach stem, though exact dimensional relationships are uncertain. Eventually, running into cooler regions, the precursor slows and is overtaken by the Mach stem. From that point on, the blast wave structure is normal again. It should be emphasized that a precursor can form only if the ground air layer is sufficiently hot. So if height of burst is increased, yield must be increased. Without the yield increase, the ground air will be too cool for precursor formation, as was the case on shot 9, our first effect shot, 26 kT at 2,400 feet. Shot 10, 15 kT at only 500 feet, developed a strong precursor. It was on this shot that we ran the smoke experiment. A carbon black smoke was established over nearly a mile of the new instrument line. We expected that the top of the black smoke would absorb thermal energy and produce an extra hot layer well above ground, possibly generating a controlled super precursor at that height, or in some other manner reducing blast effects on ground targets. The experiment was handicapped to an unknown degree by wind billowing the smoke up to 300 or 400 feet, modifying the planned geometry. As it happened, the ground-level precursor, which developed under the smoke, was stronger than the one in the clear, although it extended only half as far before decaying to a conventional blast form. We begin to bump into the precursor again. A truss bridge section 2,300 feet from zero. Shot 9, 26 kT, 2,400 feet high, produced a small permanent set in the top chord with an overpressure of 11.5 pounds per square inch. But the Mach stem had not formed to reach the height of the bridge. 8.5 pounds did this on shot 10, 500 feet high, 15 kiloton yield, with a precursor blast wave and a Mach stem already higher than the bridge. Apparently, for wind or drag-sensitive targets of this type, a low burst is more damaging than a high burst at similar peak pressures.